6 weird discoveries the science is unable to explain. So in the previous video we discussed accidentally discovered things. This video is of the weirdest discoveries of all time. In this video I'm going to reveal 6 weird discoveries that science is unable to explain, which no one told you about before. Let's grab some popcorn and make ourselves comfortable. Without wasting any time, let's get straight into the video. But before we move ahead real quick, make sure to subscribe to this channel and hit the bell icon so that you remain in touch with all of our upcoming videos. Number 1. The placebo effect. Don't attempt this at home. Several times a day for several days, you cause agony in someone. You manage the pain with morphine until the last day of the trial when you replace the morphine with a saline solution. Guess what? The saline takes the agony away. This is the placebo effect. Somehow, occasionally, a whole lot of nothing may be extremely effective. Except it's exactly nothing. When Fabrizio Benedetti of the University of Turin in Italy carried out the same experiment, he added the last twist by adding naloxone, a medication that inhibits the effects of morphine, to the saline. A surprising result? The pain-relieving effect of saline solution vanished. So what is going on? Doctors have known about the placebo effect for decades, and the naloxone finding appears to indicate that the placebo effect is somehow biological. But aside from that, we just don't know. Benedetti has subsequently demonstrated that a saline placebo may similarly decrease tremors and muscular stiffness in individuals with Parkinson's disease. He and his colleagues monitored the activity of neurons in the patient's brains while they gave the saline. They discovered that individual neurons in the subthalamic nucleus, a frequent target for surgical efforts to alleviate Parkinson's symptoms, started to fire less often when the saline was administered and with fewer bursts of firing, another characteristic linked with Parkinson's. The neuron activity reduced at the same time that the symptoms improved. The saline was clearly doing something. We have a lot to learn about what is occurring here, Benedetti adds, but one thing is clear: the mind can alter the body's biochemistry. The connection between anticipation and treatment result is a great paradigm to study mind-body interaction, he adds. Researchers now need to determine when and where a placebo works. There may be illnesses in which it has no impact. There may be a similar mechanism in various diseases. As yet, we simply don't know. Number 2. The horizon issue. Our world seems to be unfathomably uniform. Look across space from one end of the visible universe to the other, and you'll find that the microwave background radiation filling the cosmos is at the same temperature everywhere. That may not seem remarkable until you realize that the two corners are almost 28 billion light-years distant, and our universe is just 14 billion years old. Nothing can move faster than the speed of light, therefore there is no way heat radiation could have gone across the two horizons to balance out the hot and cold regions produced in the Big Bang, and leave the thermal equilibrium we observe today. This horizon problem is a huge issue for cosmologists, so enormous that they have come up with some very crazy solutions. Inflation, for example. You can overcome the horizon issue by having the universe grow ultra fast for a period right after the Great Bang, exploding up by a factor of 1050 in 20 to 33 seconds. But is it simply wishful thinking? Inflation would be an explanation if it occurred, says University of Cambridge astronomer Martin Rees. The problem is that no one knows what might have made it happen. But read inside inflation after the Big Bang. So in effect, inflation answers one riddle just to invoke another. A change in the speed of light may potentially address the horizon issue, but this too is powerless in the face of the question, why? In scientific terms, the homogeneous temperature of the background radiation remains an abnormality. A change in the speed of light might address the issue, but this too is powerless in the face of the question, why? What are your viewpoints on the discovery? Leave your comments down below. Number 3. Ultra-energetic cosmic rays. For more than a decade, scientists in Japan have been detecting cosmic rays that should not exist. Cosmic rays are particles, mainly protons but occasionally heavier atomic nuclei, that move across the cosmos at near to the speed of light. Some cosmic rays observed on Earth are generated in dramatic events like a supernova, but scientists still don't know the sources of the highest energy particles, which are the most energetic particles ever seen in nature. But that's not the actual puzzle. As cosmic ray particles move across space, they lose energy in collisions with the low-energy photons that permeate the cosmos, such as those of the cosmic microwave background radiation. Einstein's special theory of relativity predicts that any cosmic rays reaching Earth from a source outside our galaxy would have experienced so many energy-shedding collisions that their maximum potential energy is 5 to the 10 to the 19th electron volts. This is known as the Greisen-Zetsepin-Kuzmin limit. Over the last decade, however, the University of Tokyo's Akino Giant Air Shower Array, a 111 particle detector spread out over 100 square kilometers, has identified numerous cosmic rays beyond the GZK limit. In principle, they can only have originated from inside our galaxy, avoiding an energy-sapping trip across the universe. However, scientists can identify no source for these cosmic rays in our galaxy. So what is going on? One possibility is that there is something incorrect with the Akino findings. Another is that Einstein was incorrect. His special theory of relativity states that space is the same in all directions. But what if particles found it simpler to travel in some directions? Then the cosmic rays might retain more of their energy, enabling them to exceed the GZK limit. Physicists at the Pierre Auger experiment in Mendoza, Argentina are currently working on this issue. Using 1,600 detectors distributed over 3,000 square kilometers, Auger should be able to measure the energy of incoming cosmic rays and throw additional light on the Akino findings. Alan Watson, an astronomer at the University of Leeds, UK, and spokesperson for the Pierre Auger project, is already persuaded there is something worth following up here. I have no doubts that occurrences over 1,020 electron volts exist. There are sufficient instances to persuade me, he adds. The issue now is, what are they? How many of these particles are coming in and what direction are they coming from? Until we receive that knowledge, there's no knowing how unusual the actual answer might be. Number 4. Belfast homeopathy results. Madeleine Enos, a pharmacologist at Queen's University Belfast, was the scourge of homeopathy. She raged against its assertions that a chemical cure might be diluted to the point where a sample was unlikely to contain a single molecule of anything except water, and yet still have a therapeutic effect. Until that is, she set out to show once and for all that homeopathy was bunkum. In her most recent work, Enos explains how her team looked into the impact of ultra-dilute solutions of histamine on human white blood cells implicated in inflammation. These basophils produce histamine when the cells are under assault. Once released, the histamine prevents them from releasing any more. The research, repeated in 4 separate laboratories, showed that homeopathic solutions, so weak that they probably didn't contain a single histamine molecule, function exactly like a histamine. Enos may not be pleased with the homeopath's assertions, but she acknowledges that some impact cannot be ruled out. So how might that happen? Homeopaths make their medicines by dissolving materials like charcoal, poisonous nightshade, or spider venom in ethanol, and then diluting this mother tincture in the water again and again. No matter what the degree of dilution, homeopaths believe the original medicine leaves some sort of impression on the water molecules. Thus, whatever dilute the solution gets, it is still infused with the characteristics of the cure. You can see why Enos is dubious, and it remains true that no homeopathic treatment has ever been proven to function in a major randomized placebo-controlled clinical study. But the Belfast research, Inflammation Research Volume 53, page 108, indicates that something is going on. We are, Enos writes in her article, unable to explain our results and are publishing them to urge others to explore this phenomenon. If the findings prove out to be genuine, she adds, the consequences are profound. We may have to reinvent physics and chemistry. Number 5. Dark matter. Take our best knowledge of gravity, apply it to the way galaxies rotate, and you'll immediately notice the problem. The galaxies should be falling apart. Galactic stuff revolves around a central point because its mutual gravitational attraction generates centripetal forces. But there is not enough mass in the galaxies to generate this apparent rotation. Vera Rubin, an astronomer working at the Carnegie Institution's Department of Terrestrial Magnetism in Washington, D.C., discovered this anomaly in the late 1970s. The best answer from physicists was to imply there is more material out there than we can perceive. The problem was nobody could explain what this dark matter was. And they still can't. Although academics have offered numerous ideas regarding what type of particles could make up dark matter, there is no agreement. It's an embarrassing void in our knowledge. Astronomical measurements indicate that dark matter must account for approximately 90% of the mass in the cosmos, but we are shockingly unaware of what that 90% is. Maybe we can't figure out what dark matter is because it doesn't really exist. That's definitely the way Rubin would want it to play out. If I could have my choice, I would want to understand that Newton's equations must be changed in order to properly explain gravitational interactions at vast distances, she adds. That's more attractive than a cosmos populated with a new type of subnuclear particle. Number 6. Tetraneutrons. 4 years ago, a particle accelerator in France discovered 6 particles that should not exist. See Ghost in the Atom. They have termed tetraneutrons, 4 neutrons that are linked together in a manner that violates the rules of physics. Francisco Miguel Marquis and colleagues at the Ganil Accelerator in Cayenne are now gearing ready to do it again. If they succeed, these clusters may compel us to reconsider the forces that keep atomic nuclei together. The researchers fired beryllium nuclei at tiny carbon targets and examined the debris that flew into surrounding particle detectors. They anticipated finding evidence for 4 distinct neutrons striking their detectors. Instead, the Ganil team detected only 1 flash of light in one detector, and the intensity of this flash indicated that 4 neutrons were coming simultaneously at the detector. Of course, their discovery might have been an accident. 4 neutrons could simply have arrived at the same spot at the same time by chance. But that's extremely unlikely. Not as unlikely as tetraneutrons, some would argue, since in the conventional model of particle physics, tetraneutrons just can't exist. According to the Pauli exclusion principle, not even 2 protons or neutrons in the same system may have identical quantum characteristics. In fact, the strong nuclear force that would keep them together is calibrated in such a manner that it can't even hold 2 lone neutrons together, much alone 4. Marquis and his colleagues were so puzzled by their findings that they hid the data in a research article that was purportedly about the potential of discovering tetraneutrons in the future. So everyone, that's all we have for today. If you have any weird discoveries that you would like to talk about, please leave them below in the comments. Also, don't forget to like, share, and subscribe to our channel so that you can be notified of all of our upcoming videos.